Hello, can you hear me? Awesome. So we had some great talks today so far on the security track. I'm going to talk about secrets to monitor Kubernetes workloads. I tried learning Malayalam after coming here, but didn't succeed a lot. I could only learn two words. So the first word is here, and the last one is on the last slide. But yeah, let's start. Who am I? My name is Prathamesh. I was a developer in past life. Now I'm a developer evangelist at Last9. I run few things on the internet. You can find that on my socials. One of them is SRE stories. If you are an SRE and want to share your story with the world, come meet me after my talk. I'll record your story and publish it on a blog on SRE stories. I also run a Oli wiki where you will find all the terms related to observability. So that is also one of the open source project that I run. By the way, I am also a t-shirt distributor for Last9. So everywhere I go, I carry these t-shirts that I'm wearing. If you want this one, then just fill up your details on last9.io/friends and we'll get it shipped to your address. But the only rider is you have to do it before my talk ends. Otherwise, it doesn't apply. Actually, that was a wrong idea because you will keep filling the form. Please do it after my talk. Okay, great. So the agenda for today is we'll discuss why you should care about this topic of monitoring Kubernetes and its workloads. We'll talk about why monitoring is important with respect to observability. We'll talk about the relationship between Prometheus and Kubernetes, how they are basically meant for each other in terms of the interop that is available. We'll talk about some of the challenges as well while running Prometheus and Kubernetes at scale. And we'll discuss some of those solutions to those challenges as well. And if time permits, I think my timer is. So yeah, let's start. By the way, if you want to tag along with me, this is the QR code for my slides. So just scan it and you will be able to see the slides. So even if I miss something because of the time constraint, you will be able to check it. Okay, great. So why should you care? How many of you don't use Kubernetes? Only one person. That's why you should care about this topic. All of you use Kubernetes, you should know about how to monitor Kubernetes, right? Kubernetes has become almost the de facto standard for running microservices and modern applications. And it's important to understand how the workloads are behaving so that we can take actions about fixing issues proactively rather than our customers telling us, oh, something went wrong and please fix it now. If you look at Kubernetes architecture, I think there are a lot of talks on this topic from the morning, but it's a bit complicated. There are a lot of components that are involved in Kubernetes. There is control plane, there are deployments, there are logical entities, pods, nodes, containers, blah, blah, blah. There are too many components out there. And all of them are interconnected with each other, right? So when you think about monitoring, the question arises that what should I start with or what should I omit? What should I care about more, right? These are some of the questions that we'll try to answer today. And of course, it's fun to learn new things. So maybe you will learn something new after this talk. So let's give it a try. Before we go deep into Kubernetes and Prometheus, let's talk about what do I mean by monitoring, because most of the time these terms are very convoluted. Like when you Google monitoring, you will find 10, 20 definitions of what each person means about monitoring. So I want to focus on monitoring from a specific angle, and I'll start with that. If you look at observability from the lens of a radar and a black box, then things become very clear. You want to have a radar view which can tell you what's happening across your clusters in real time so that you can take quick decisions, mitigate the incidents before they really become downtimes for your customers. At the same time, you still need a flight recorder black box which can tell you how to debug or why something has happened. But that's almost a post-factor activity, right? You still need a solid monitoring strategy from an observability point of view. Because if you don't have that monitoring strategy, the time wasted in debugging incidents becomes very crucial and that impacts your customer experience. So we will focus on the left hand side. We'll talk about monitoring and how it can help us understand behavior and performance of our Kubernetes clusters. So most of this talk is about charts, graphs, alerts, and time series data. That's all we'll talk about. We'll not talk about logs, we'll not talk about debugging, we'll not talk about anything else. So most of the conversation will be around these three core ideas: charts, alerts, and time series data, which is metrics. Now, the question that arises when we think about monitoring is who is the persona that is monitoring, right? Like there are different people in our organization and in our teams that are involved in running these software systems. There can be an operator or an SRE team which is responsible for maintaining health of clusters. There are application developers who are responsible for API latency or availability of certain endpoints. Then of course there are product managers who are involved, interested in knowing which of my product workflows are getting adopted more. And at the end there is business who is interested in knowing about what is my bottom line, right? Am I losing money because customers are not happy about the experience that they are getting? So when we think about monitoring, we also have to think about all of these use cases, because monitoring is not just for infrastructure. It involves different personas and their different use cases have to be addressed when we think about a monitoring strategy from an organization point of view. And it's not just people as well, right? Time also matters. You are monitoring when you are debugging or fighting an incident. So you're monitoring during wartime, but at the same time, you're also monitoring during peacetime. You want to do a retrospective analysis, organization overview, making sure that you're meeting the objectives that the organization has set. So long-term access to data and those kind of things also become very important in terms of doing monitoring during wartime versus peacetime. So everybody has a wish list about how their monitoring should be and what it should allow you to do. I have tried to capture that wish list in this slide. So you have 5 stages of your monitoring landscape. Starts with instrumentation and goes up to alerting. So query layer is all about visualization as well as query. Then you have ingestion, storage, and at the end you have alerting, right? Instrumentation, open standards based, becomes very crucial so that you can get up and running very quickly, and that also helps you piggyback on existing tools that already exist in open source world, right? You can literally use all the innovations that are happening. You can be on the curve of latest innovations. So on the instrumentation side, open standards becomes very critical from a wishlist perspective. You don't want to get vendor locked in with a proprietary protocol or a language that is hard to use in other contexts. At the ingestion side, you need to have some control over what data is getting ingested. Maybe have an ability to downsample some data or put dampeners, reduce the samples that are getting ingested so that you can control the flow. It's all about having some control over the data before it gets stored. On the storage side, long-term storage for things like doing capacity analysis, understanding what have been the trends over a longer time horizon instead of just looking at from a limited 7-day window or 14-day window. And also faster access, that depends on how isolated you, how the storage has been isolated for different use cases, because you don't want to run into a situation where there is a single point of failure in your storage system where alerting and querying from your dashboards is going into the same storage layer, which is causing issues with the reliability of the storage layer itself, right? You don't want to run into those kind of situations. On the query layer, we need a standard query interface, need of standard dashboards so that we all can speak same language at an organization level. When different teams are deploying different applications in their Kubernetes environments, they should speak the same language in terms of what the performance means or what the particular service delivery index means, right? So that becomes very critical. From the alerting point of view, the biggest challenge that everyone faces is around fatigue, coverage, irrelevant alerts. We don't know why we are getting these alerts. Let's just ignore it. There is Slack channel in every organization that nobody looks at. Please correct me if I'm wrong. Maybe you have a Jira or a PagerDuty, I don't know. But there is some destination where alerts are getting dumped and nobody looks at it, right? So it's important to have better alerts with relevant context so that we don't run into a situation where actually an alert happened and that got missed because we were already desensitized to irrelevant alerts. So this is the wish list. We'll see if we can achieve it with existing tools. and we'll see if there are any gaps in achieving that wish list as well. So that's the agenda of the talk. Now coming back to monitoring, what do we monitor at bare minimum, right? Like what is the bare minimum that we can do? Of course, you want to monitor the Kubernetes components themselves. That is the first part. But you also want to monitor the applications, jobs, services that are running on that Kubernetes clusters, right? So on the left-hand side, you're monitoring all the Kubernetes components. That becomes important from an operator perspective or an SRE perspective, because they are responsible for maintaining health of all of these components. And on the right-hand side, we are talking about monitoring these services, containers, jobs, which are actually running logical workloads, the actual business logic that is being run. So this is the aim that we want to achieve. Good thing about Kubernetes is it already emits certain metrics in standard open metrics format for all of its components. So all the internal Kubernetes components, they already emit certain metrics that we can use, right? So one of such component is kube state metrics. It emits standard state metrics about a particular component, like what is the state of my pods? Are they ready or are they currently not even scheduled? What is the status of my deployment? Is it on or off, right? I will get all those state metrics via kube state metrics. There is metrics server which basically emits all the performance metrics, like what has been the CPU utilization, what has been the memory utilization for especially nodes and pods. Then there are C-advisor metrics, which are all about container level performance metrics, right? Because Kubernetes has these pods, nodes, containers. So there are different components that emit metrics for each of those. You have Kubernetes control plane, which basically emits the cluster health metrics, which give you a high level overview of the health of the cluster at any point of time. So from an infrastructure perspective, you are already covered, because if you just use these components by default, you will get all of these metrics out of the box, and that should mostly cover your infrastructure use cases. On the application services side, we will talk about standards like rate, error, duration, right? Like all languages can fall into this category of throughput, error rate, duration, latency, because every web application will conform to this idea of standard metrics. If you have background jobs, async workers, they can have utilization, saturation, and other like utilization related metrics. You also have an ability to do custom metrics. If you want to emit certain business metrics, there are client libraries that you can use to emit custom metrics as well. You might guess where I'm going with all of this, right? Like with Kubernetes, you also run into a specific challenge of ephemeral resources. How many times you have seen pods getting, like pods dying very quickly? Like new pods coming up within 5 minutes, 10 minutes of an application rollout. Has anybody seen that? Maybe some of you, right? So typically what happens in that case is your pods are getting churned, because new pods are getting created automatically depending on the service definitions or deployment definitions that we have created. And that results into new data about those pods getting emitted, because every pod will have its own unique ID, which will result into like unique data points getting created whenever a new pod or container is getting created. So ephemeral resources and service discovery is a critical challenge that a monitoring tool should solve for if it has to work with Kubernetes workloads. Now with all these constraints and the things that we want to solve for, anybody has any guess what kind of tool can solve for this with all these constraints?
Prometheus?
Okay, great. So let's think what can solve like such kind of problem. So basically all the roads of Kubernetes monitoring lead to Prometheus, because Prometheus can solve for service discovery, it can solve for custom metrics, it can solve for exporters, it can solve for all your read use metrics, and Kubernetes already emits its own metrics in open metrics format, right? So it's a match made in heaven already, right? You can use Prometheus to monitor both the sides of the coin, not just the infra, but also on the application side. And if you look at history of Kubernetes project and Prometheus project, actually they were inspired from the original Google projects, right? So this was one of the quote that I took from one of the interview of Julius Wolz, who is the co-founder of Prometheus, and he discussed about how Kubernetes was inspired from Borg, which was Google's container orchestration system, and Prometheus was inspired from Borgman, which was built to monitor Borg, right? So Prometheus was built or designed on the same principles of Borgman, which was built to monitor a container orchestration system like Kubernetes. So, and of course, both are CNCF graduated projects as well, which also makes them likely candidates for wide adoption. So that's established now. We'll talk about Prometheus. We will use Prometheus to monitor our Kubernetes workloads. The architecture looks somewhat like this. I don't know if it is visible at the back, but you don't have to worry about this. This basically means that Prometheus will auto-discover all the resources that are out there in your Kubernetes cluster, and it will start tracking those in its target list for getting the metrics. Now, with Prometheus, again, we will look at our diagram. We started with instrumentation, ingestion, storage, query, and alerting. Let's look at it from the lens of now using Prometheus, right? So, on the instrumentation side, we have service discovery. We have standard K-test metrics that we talked about. We have exporters, which can basically give you metrics from non-standard components as well. On the ingestion side, the ingestion happens in open metrics format. There is also a text exposition format that Prometheus supports. And it works on a pull-based model, right? It scrapes data from all the targets instead of targets needing to push it. So it works in a very flexible manner where it can collect data from different targets in real time and store it. On the storage side, you have multi-dimensional data model, which is based on labels. So if you have a pod label, instance label, deployment label, like Kubernetes have different attributes with a particular resource. All of them are mapped one-to-one with Prometheus labels for specific metrics. You also have an ability to do long-term storage, so you can remote write to a durable storage. You can use Thanos or any other commercial vendors as well if you want to store your metrics for long-term. So that problem also gets solved. On the query layer, we have PromQL, which is the standard query. You have Grafana for visualizing the dashboards, creating new dashboards. There is like built-in Prometheus visualization as well that comes out of the box. And you can of course find out a lot of standard dashboards on Google as well for specific use cases. Like if you just search Kubernetes dashboards, there are tons of dashboards already out there that can get you up and running. Cool. On the alerting side, also the problem is solved. I'll just skip through this. You may read it later, but alerting also you get some defaults with respect to where you can send those notifications and so on. But are there any challenges in doing this, right? Like we saw the good side of using Prometheus for monitoring Kubernetes workloads, but are there any challenges that we should be aware of when we want to actually deploy this in production? So the next part of the talk will look at some of the challenges that we need to be aware of when we are running this in our production environments. But let's get started for now. We don't know what are the challenges. We'll just get started with the first step, which was the setup and the instrumentation. If you Google how to monitor Kubernetes workloads, you will find a lot of Google results. Ignore all of them, just use Prometheus. That is the best way to get started with setting up Prometheus for your Kubernetes clusters. What it does is, it creates all these resources. So you get, basically you get Prometheus, you get Alert Manager, you get Node Exporter, you get Grafana, Black Box Exporter, everything. Right? And this Prometheus takes care of doing HA setup as well for your Prometheus and Alert Manager. So out of the box, you get all of these components installed. How it works internally is it uses an operator, which is Prometheus operator for Kubernetes, which takes care of service discovery. So it uses some custom CRD definitions to discover new services. We don't want to go into too much details into it, but just remember that it will take care of your service discovery and figure out new resources and services. That's great. So on the instrumentation side, we have a ready way, an operator that we can use, which solves for service discovery. And we also have an ability to monitor new services and components that are up and coming in our infrastructure. So instrumentation looks good so far with Prometheus. Doesn't seem to have a lot of challenges. Let's go to ingestion. So how many of you ingest data in your Prometheus, which is, let's say, beyond 1 million per minute, 1 million samples per minute? One. Great. Okay. Yeah. Okay. Thanks. So I'll skip some of this part, otherwise we'll go over time. But ingesting large volumes of data is rarely a problem with Prometheus. You can ingest as much as you want. Typically, the challenges that you run into are when you start querying more and more data. As long as you don't query, you're good. You can store the data in your storage. You just have to increase perhaps your PV persistent volume, and the data will reside as it is. As long as your system is not really primed for a large scale use, you should be okay. And the default storage that Prometheus comes is 14 days. So if you're not going for like 6 months, 12 months, you should be fine. But the challenge happens when you have larger workloads for read workloads and longer time retention. The biggest challenge that happens at the ingestion layer because of lack of workflows is the high cardinality challenge. How many of you have heard of this term, high cardinality? Okay, some of you, right? So high cardinality is basically a combination of different unique time series that ultimately chokes your storage layer. Because as your ephemeral pods and instances increase, it creates those many unique combinations of label pairs, key value pairs. For example, if I have 4 clusters and 1000 services, 3 environments, 10,000 pods, if I multiply all of these, it will ultimately result into 12 million unique combinations of data, right? And that means that my storage is already storing a lot of unnecessary data. Maybe most of those 10,000 pods no longer exist now, because on an average I run only 100 pods, but most of those pods got created because of some service discovery or restarts or any other activity in my Kubernetes cluster. So I'm unnecessarily holding on to data that I can't even use for any other actual usage. Solving for high cardinality is out there. There are ways to solve that. So you can do things like downsampling, which Thanos allows you to do. You can drop labels as well. You can have relabel configuration, drop certain labels, create smaller subsets of your time series data. But all of these run into the same challenge. How many of you have read a book called as Same as Ever from Morgan Housel? Has anybody read that? Probably no. So the key idea that he talks about is it's difficult to make predictions, right? It's difficult to predict at the instrumentation type that which of my labels will grow, which of those will cause spikes after a month or so, right? And that makes adding relabeling or these rules very difficult, because I have to almost go back and change my instrumentation to solve for cardinality instead of solving it after the instrumentation layer. So coming back to the challenges with ingestion, it has certain capabilities for dropping cardinality, but cardinality is not really like a completely solved problem. If you don't solve for it, you of course result into higher compute costs and total cost of running your Prometheus infrastructure. On the storage layer, again the same challenge happens. Millions of metrics, mostly unused. Data exists, not accessible when you actually need it. This results primarily due to lack of workload isolation, because you don't have a way to say that, oh, my alerting needs access to only a fresh data, like let's say 2 hours of 6 hours of data, but I don't have a way to segregate that because I have a single storage there where all data is getting pumped. And that's where you run into this challenge of like having a single point of failure for your storage. You can do remote write with Thanos and other vendors like Levitate and other stuff, where you can push it for long term. They will take care of the durability and storage guarantees. But with stock Prometheus, you may run into challenges. So cost becomes a concern. As your data increases, you may run into cost challenges. Remote write can save you. Query, again the same thing, you are fine as long as you are not reading, because the same challenge happens at the query layer. As you become, as you add more and more queries, alert rules, the storage becomes a choke point, because everyone is trying to access the same data at the same time. We have had customers who have told us interesting scenarios, like during a live event, basically they had a war room, and their engineering managers basically asked all the 13 SREs to come on a call, and then he shared the Grafana dashboard instead of everybody else looking at their own Grafana dashboard, because the Grafana was choking at that time because the storage layer was not able to keep up. Solution is you can either limit instrumentation, you can limit query range, you can reduce the amount of data that you're trying to load. Effectively, all of this results because of lack of traffic shaping abilities. Alerting, the biggest challenge is fatigue. You have too many alerts, you don't know why they're happening. There is always a problem of signal versus noise. A lot of times the default visualization that comes with Alert Manager and Prometheus, you don't have access to the historical trends. So you don't really know whether this alert has been happening for last 7 days, or does it happen every day at 4 a.m., right? There is a lot of time wasted in understanding those trends. With respect to the traffic, if you have seasonal traffic, Prometheus by default doesn't have an ability to do seasonality based alert detection. Like there is no ability to do spikes or any other anomalies. That may also limit you based on your use cases. There are some sane defaults that you can get started with. So this is one of my favorite library, samber.github.io, which is awesome Prometheus rules. And you can just start using these alert rules by default. They work pretty much in almost all the cases. But there is a dark side to that as well. The dark side is basically if you use something without understanding your data shape, then you may run into a situation where you're using high cardinality labels in alerts and dashboards, which effectively results into latent dashboards, invalid alert rules. Like you're using a rule, but you don't even have that metric, or you don't even have the label that is being used in that alert rule because you copy pasted it from the internet. So those kind of situations may happen. But mostly on the alerting side, apart from the anomaly and the visualization layer, we should be okay. We do have a support for basic alerting. This is a security track, so I need to have a slide on security. Otherwise, it doesn't make sense, right? If you are running Prometheus with respect to the prom operator on the cluster itself, you don't have to worry about security. You will basically inherit the security certificates that the Kubernetes cluster has. The challenge happens when you want to run like a central Prometheus. I was just talking to someone in the morning, and he was telling me the same problem, that they want to run a central Prometheus, but security becomes a challenge. Cool stuff. I think we still have 4 minutes, so yeah, I finished early. There is some cool stuff. You can actually reduce your Kubernetes metrics. It is possible. There are open source tools available there. One of the best idea is basically drop everything that is not there in your alerts and dashboards. While it restricts you from the future usage perspective, at least it can solve the pain in the meantime, right? So there are tools like Mimir tool that you can use to understand like which metrics you are using in your Grafana dashboards and get rid of everything else. Did you know that you can actually use Prometheus metrics to also auto scale using the HPA? So there is a Prometheus adapter that you can use and plug in the Prometheus metrics back to the HPA layer itself of Kubernetes, so that you can do auto scaling. And this provides a much more powerful way, because now your HPA rules are actually dependent on the real metrics that are happening in real time. So this is one cool stuff that you can do. For managing cardinality, you can also do streaming aggregations. Basically, you can run aggregation rules before the storage layer to reduce the cardinality. The advantage here compared to recording rules is this happens before the storage instead of having a query penalty or a storage penalty after the like the data is stored. What I have here as an example is an HTTP request metric, and this is a very classic case of people shooting in their foot, right? Because you are observing API performance or an application performance, which is, let's say, per endpoint or per like controller or per method of the particular endpoint, right? You don't really are concerned about instances and pods here. But because you're storing those instances and pods, because the data is coming from Kubernetes containers, you have a large search space of samples that effectively affects your query performance. What you can do here with this streaming aggregation is, I'm grouping on endpoint and method and ignoring everything else, right? So my instance, pod, and all the other labels that I don't need are discarded right away. And now I can use the new metric in my dashboards and alerting queries, because here I'm not really interested in knowing more about instances and pods. So this gives me an ability to have these like purpose-built metrics that I can use for specific use cases. So yeah, we saw these challenges in terms of monitoring the Kubernetes workloads, and that's all I have. This is the second word that I learned after coming here. You can know more about us. You can scan this barcode, and that's it. Thank you.